talking about coordinate planes today. All right, we are currently recording. I am going to share screen. Today is Monday, so we are doing math. We got the good old Monday math going on today. And today I want to introduce you to some, or not introduce you, pardon me. Hopefully you all know this very well, but I want to remind you of some really important information about the coordinate plane and what you're going to be going into with linear functions and graphing translations and similarities in shapes, which I know you did in 7th grade, where you have like a triangle and it's a 3x2, you expand it and it's a 6x4, so it dilates. So there's dilation, transformations, all of that. And you have to be really comfortable with the coordinate plane in order to do that. So this is a website called Desmos. It's helpful if you're just trying to graph things and you don't have graph paper, because you can just put the coordinates in here. It's not super user-friendly. So if you wanted to play around with this later in your life, you're absolutely welcome to. But today I'm just gonna kind of show you some baseline stuff that hopefully we all remember. So this is a coordinate plane, coordinate. There are coordinates on it, like Battleship, where you say like L7. Well, we're gonna go to like the X coordinate and we're gonna go up 7. So this can tell you, you can use this in so many different ways. We can draw scales with this. You'll need this for finding points of origin. If you're trying to measure a building and you wanna know how can I make this parallel on both sides, you can create a coordinate plane and do similar shapes and figures. So I want to show you some baseline stuff that we need to know for this. And first, very important is X and Y axis. So your X is your horizontal. Now, I always remember horizontal by the horizon. Like when you look out at a sunset, you're looking out at the horizon. So the horizontal is your X. Your vertical, up and down, is your Y. There's not really a great way to remember that, except your coordinates are always X, Y. So it's always this way and then this way. You go over, then you go up. That is a very common mistake, that we mix up our X and Y axes, and axes is this line. So one more time, horizontal is X, vertical is Y. If you have a great tool to remember that, if there's some way you can remember over then up, please let me know, because I just had to remember it. So that's a common mistake we make, is mixing up our axes. So one more time, horizontal is X, vertical is Y. Now, you have your coordinates are always going to be X, comma, Y. You're never going to get a set of coordinates that says like 4, 6, and the 6 is your X. It always is going to be X, comma, Y. So that helps you to go over then up. Go over the first number and then up or down the second number. So the values in these boxes mean things. So let me go ahead and get my window open so we can take notes. Oh, that's my decoration for next year. Don't look at it, it's special. Give me 1 second to go into my notebook. Ms. Humphreys is not taking notes, which we know is wrong. We write down even if we know it. Hi, open please. Thanks. There's my email. Feel free to hit me up anytime. Still checking it. Making sure you guys are doing good. All right, we're gonna go to OneNote, summer sessions. And there was no science on Thursday because Ms. Humphreys was sick. So we are going into math for today. Remember, we did variables and angle pairings. So we are going to go on to the coordinate plane today. And shocker, that's not how you spell coordinate. Coordinate plane. Okay, so we have horizontal. Horizontal is the x-axis. We have vertical is the y-axis. And then we have the pairings are always going to be x comma y. So you will always go over and then up. Okay. Now, there is a point of origin, which you'll hear commonly asked, start at the point of origin, and that is going to be 0, 0. This little dot right here in the center, your point of origin in terms of calculating in geometry is always going to be this 0.00, or excuse me, 0, 0. So point of origin Y'all, it's getting worse over summer. I can't spell anything. Point of origin is 0, 0. Okay. Now, how do we move around this thing? What do the little boxes mean? Why do we care? I feel like I remember something about quadrants. Great job. Let's look at it. So you see that there, when I cross two lines, I create 4 boxes. We have a box here, 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 and here. And no matter how far out I go, I still have those 4 boxes. I have here, 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 and here. So you'll notice here it says quadrant 1. Well, I'm going to add a positive and a positive. So I'm actually going to go, oh, no, plus sign this numbers. Ah, yeah, she's killing it. She's killing the game. Okay. If I come here, you'll notice that this is labeled quadrant 1. It's saying that I have a variable in quadrant 1. Now, both of those numbers are positive. So that could indicate to me that quadrant 1 is made up of a positive and a positive. We all know numbers can both be positive and negative, right? We remember our integers. Oh, stop doing that. We remember our integers. We remember that numbers can have positive and negative values. So we're going to look at this as I go up, I go over, always over first, and all these numbers are positive. And I go up, all these numbers are positive. So when I'm in quadrant 1, it is positive, positive. Now, mindset that's complicated to like put into your mind. A coordinate plane goes counterclockwise. You would assume it's quadrant 1, quadrant 2, 3, 4. It's the opposite. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. They go counterclockwise. So points of origin, quadrants, why can I not spell today? Quadrants go counterclockwise. So when I'm looking at this board and I know that my top right is quadrant 1, I go counterclockwise, 2, 3, 4. Well, if quadrant 1 was made up of a positive and a positive, let me look at quadrant 2. Well, it's telling me that these numbers down here are negative, and I know that my horizontal is x, so I know my x is negative. So my x value is negative, so I'm going to indicate that with that symbol right there. And then I know I'm in this quadrant, so I have to go up. Well, the y-axis is positive. These numbers right here on this y-axis are positive. So I have a negative and a positive. So quadrant 2 is made up of a negative and a positive. So logically, this makes sense. If I go into quadrant 3, which is bottom left, quadrant 1, 2, 3, I'm going counterclockwise. So let me show you quadrant 4. Let's do -4 and +7. I'm in quadrant 2. All I did was change my x, quadrant 1, to a negative quadrant 2. So if you look here, the only thing I did was change my x from positive to negative, and I moved quadrants. Now, I went from 1 to 2. I'm going to come to 3. Well, if I look into my corners of 3, both this number and this number are negative. So let's see what happens when I change that to a -7. Boom, I'm in quadrant 3. So both x and y are negative. So in quadrant 3, my x and my y are negative. We just proved that. So one more time, let me show you when both numbers, oh, spoiler, when both numbers are positive, we're in quadrant 1. When the x is negative, we're in quadrant 2. When they're both negative, we're in quadrant 3. So what do you think happens if only the y is negative? Beautiful, quadrant 4. So logically, that means quadrant 4 is made up of a positive number and a negative number. Now, why do I care? Why is this helpful to me? Well, if you know these things, if you know these general idea of where it's supposed to go, and I give you coordinates 4, 7, +4, +7, and you're plotting it, and you put it in quadrant 4, you mess something up. We done plotted something wrong, right? If I give you 2 numbers that are positive, and you are not plotting them in this quadrant, you've plotted something wrong. So there's a great easy check-in right there. So that's why we need to know the symbols of each, because it's also going to be easier for you when it tells you that. So remember, it always goes x, y, and here are your quadrants. Okay. So let's see. What's an easy way to do this? Oh, positive and negatives on the quadrant. Okay. So when I get a number, how do I know what to do with it? So let's look. Example. I give you the coordinates -2, +4. You go on to this quadrant. Let's empty these out. So we're at the origin. You can't see what I'm doing. Okay, so we have -2, +4. Well, I'm gonna zoom in. Oh, in. Okay, -2, +4. Well, here I have a pause. I know first is x-axis. I know that first number is my x, so I know it's horizontal. So I'm looking for a -2 on this number line. That's all this is a number line. So I see a -5 here, and I see a 0. So it's got to be somewhere in between here. So I have 1, 2, 3, 4, 5. So these are 1 variable intervals. So I go 1, 2. So my -2 should be right here. So let's check and see if we're right. -2. So my -2 should be right here. Then my other number was 4. Well, again, I've gone over, and then I go up or down. Well, it's a +4, and here's a +5. So I'm going to go up 1, 2, 3, 4. My number should be right there. That dot right there. Let's see if we're, what did I say? 4. Boom. Look at us go. Right there. 4 and -2. We are in quadrant 2. Our dot goes right there. So how do you know which way to go? Well, if your x is negative, you go left to the negative numbers. If your x is positive, you go right to the positive numbers. Seems logical, but we can always mess it up, right? Miss Humphreys always finds a way to mess it up. So on our x values, you can have positive or negative. When your number, we also in math, it's just important for you to know, unknown number or number, yes, you have variables, which are x, but in statistics and going into your life, we're going to call it n. An unknown number of things is n. So when your number, or n, is negative, you go left towards the negative. If it's positive, you go right towards the positive numbers. All right, so what do you think happens with the y values? Well, let's do another example. If we are at -2 here and +4 here, we're up in quadrant 2. Well, if I do -4, boom, I'm down here because we know negative and negative. So I still went over 2, but rather than going up for positive, I went down for negative. All I'm doing is reading this number line. That's it. So x values can be positive or negative. And when the number is negative, you go down. Positive, go up. So that is literally a reminder refresh of both how we plot and read a coordinate plane. So let's find an example of finding the distance between 2 points. Why do I care about the distance? Okay. Good old distance formula. You have 2 coordinates, okay? I'm going to have 2 dots. 2 equals 5. Okay. Cool. I don't know how to use this. Told you it's not very user-friendly. All right. Movable points. What are you mad about? Give me 1 second, guys. One second. Nope, I don't like it. Hold on. Okay. That's not helpful. Shocker. All right, whatever. Okay. Miss Humphries can't find it. It's fine. All right. So basically what we're doing when we are trying to calculate the distance formula is how long are two things away from each other. So the importance of this is that if you are trying to take the hypotenuse, we remember our angles, right? The longest side is the hypotenuse. If we're trying to find the shortest distance between 2 points, if we're trying to measure how much material we need to build a fence on these 2 points, anything that you can take on a quadrant, take 2 points and figure out the distance between. There's 1,000 reasons to do it. Well, if I have 2 points, then don't I have 2 x's and 2 y's, right? Because I have the first coordinate that I took and the second coordinate that I took. Well, the way that we tell the difference, because these 2 coordinates go together, you can't just be mixing up x's and y's, is that we do sub numbers. So you'll see subscripts are the opposite or very different, not the same thing at all, as exponents. So you'll see like subscript. Let me just draw it because it's going to take me 16 years to find. Okay, so we're going to have x and y, right? And then x and y. Well, these two things go together. You can't just be mixing them up. So the way that we negate or tell you what they are is this subscript. There's a number underneath it that indicates that it's part of that situation. So we have x sub 1, y sub 1 is one coordinate. Then x sub 2, y sub 2 is one coordinate. So you can't have x sub 1 and y sub 2. Those aren't related to anything, okay? The reason we're looking at them as x's and y's is because we're going to see how far apart they are this way and how far apart they are this way. That's going to give us the overall. So you cannot mix up the numbers. These subscripts are very important. And also don't confuse them for exponents, or you're like, I'm trying to square an x and there's, I don't know. No, under is different. In chemistry, these subscripts are going to tell you how many of an element is in a compound. You'll see a lot of subscripts in 8th grade. So now we know what these mean, x sub 1, y sub 1, x sub 2, y sub 2. You have an equation for the distance. Oh, not at all, Miss Humphries. Not even close. That was awful. Back that up. Undo. Yes, that was a mess. Okay, let's try that again. What is this? A square root. Perfect. We know that we are taking the square of a square root. And then what are we taking the square of? Well, here's our fun equation. X what? Great question. Sub 2. So this x minus x sub 1. So minus this x. Well, we're going to square that. Plus y sub 2 minus y sub 1. Now, notice there is a very clear pattern. It's 2 minus 1 plus 2 minus 1. Do not, watch, I promise you, I've done it, I've seen people do it, I've graded tests with it done, it's just tragic. Let me give you an example of what the most common mistake you're gonna do is. Let me give you set 4,6 and set 8,3. Okay, notice these are different. Oh, like an hour and a half. I'm gonna still eat it, don't get it twisted. Sorry guys, my mom was being helpful and bringing me food. Okay, so here are my two sets. I know these are 1 and this is 2. Well, my equation says to do x sub 2 minus x sub 1, that's a 2, plus y sub 2 minus y sub 1. I promise you, someone's gonna do x sub 2, 6, minus x sub 1, 4, plus y sub 2, 3, minus y sub 1, 8. These are x's and y's. That is not how that goes at all. Be very, very, very careful of the numbers that you're putting in there. You will mix up your x's and y's. You will put y's instead of x's. You will, I promise you I've done it. It is the hardest to transfer those numbers. So what I do, and I know you're like, oh my gosh, extra steps. Don't care. I go through and I label them. As soon as I get my numbers, I say x sub 1, y sub 1, x sub 2, y sub 2. So then I'm literally just plugging and chugging. I don't have to think about anything. So I'm going to erase this, erase this horrid nonsense that makes no sense. And I'm going to do it correctly. I'm going to draw my thing. I'm going to follow my thing, x sub 2. X sub 2 is 8 minus x sub 1. I look for x sub 1 is 4. Then I add my equations plus y sub 2 is 3 minus y sub 1 is 6. And then I promise you, so many people are going to forget to add your squares there because your square and your square root undo each other. So all we're at now is 8 minus 4 is 4 squared plus 3 minus 6 is negative 3 squared. So I'm down to a simple addition, square root. Well, if I take 4 times 4, 16, positive 16, right? A negative times a negative is positive. 3 times 3 is 9. Square root of 9 plus 16, well, 9 plus 16 is 25. The square root of 25 is 5. Now, could I have skipped some steps? What's 4 plus 3? 4 plus negative 3 is negative 8. So, or excuse me, 4 plus negative 3 is 1. So that answer is not going to give you the same as that answer. I know it seems simple and logical to go ahead and just mark them out, but order of operations matters. Order of operations is incredibly important, and you can't just start messing with stuff under a radical and get rid of it all, okay? Follow your steps, follow your procedures, you'll get there. So this one is a little tedious. You do have to kind of follow along to get distance formula, but it's going to be very helpful in calculating hypotenuse and trigonometry and calculus. Or excuse me, trigonometry. So let's do one more example of the distance formula. And then I'm probably gonna let you go because it's Monday and it's raining. And also Miss Humphreys is a mess and hasn't eaten lunch. Okay, let's try again. Let's do coordinates 7 and 8. And then coordinates, let's do 9 and 10, just for fun. All right. Here are our coordinates. Our very first step is to label x sub 1, y sub 1, x sub 2, y sub 2, and then we write our original formula, which is x sub 2 minus x sub 1, remember the squared, plus y sub 2 minus y sub 1, remember the squared. All right. Once we have it, we're literally just plug and chug. We love a plug and chug. So let's come down here, clear the rest of that mess off. Come here. All right, let's draw. Square root, x sub 2, x sub 2, x sub 2, 9, minus x sub 1, 7. Drop my squared. Bring my plus, y sub 2, 10, minus y sub 1 is 8. Squared. All right. Now, Miss Humphreys, why can't I just mark out that squared with that squared? Because order of operations. We cannot mess with an exponent until we do the radical. Those are going to cancel each other out. We have to solve what's under the radical first. So 9 minus 7 is 2 squared, plus 10 minus 8 is 2 squared. Now, notice, what did I do? What mistake have I already made? I did not bring down this radical. You have to bring this. There are so many steps that you have to follow and be precise, and precision is not always our best strong suit in middle school when we're trying to be done so we can go draw or do whatever we want to do. All right, so 2 times, which an exponent is just repeated multiplication, right? 2 times 2 is 4, plus 2 times 2 is 4. 4 plus 4 is 8. So the answer is the square root of 8. Now, I don't believe you guys have yet, but you can. I'm just going to give you a real quick little snippet of simplifying radicals because the square root of 8 is not perfect. So we're going to look at what those things give us. Square root of 8. 8 is made up by 4 and 2. 4 is made up by 2 and 2. Well, I see a pair here. So that pair has been removed, and then I have a pair here. and I have a remainder there. So my technical answer is 2 root 2, or square root of 8. Simplifying radicals will be a new task that we will learn next week. So that is a coordinate plane and distance formula review. Again, the notebook is here. This video will be on YouTube. The link to the notebook will be in the YouTube description. Here I will add, I don't know if I have any of these. I'm going to look in my Google Classroom and try to find some examples for you. Again, access to the Google Classroom. Let me just show you that while we're still recording. And then that'll be it for today. I was meeting with some other teachers and they were like, your video should really be no more than 5 minutes. I was like, that's cute. Okay, so if you want to join this, you're just going to go to Google Classroom and you're going to put in this class code here, 3QVKSJH, and that is going to get you into this 7th grade and 8th grade math. And here's all of the classwork again. Let me just show you. Here are examples and keys for help, operations with decimals, fractions, expressions and equations, ratios and proportions, finding slope, dilations, proportions and scale factors, geometry, probability, exponents, Pythagorean, distance formula right there. So we come in here and we have a practice sheet, which gives you some different options that you're welcome to ask me to solve. Here are some example practices that you can pick your different coordinates and just try it on your own. That'll walk you through it. And here is some explanations with homework of exactly how to run through this with more practice. So I will post, actually this looks like a great resource. I'm going to post this one. Post this one onto the classroom notebook, so you will have that available to you. Let's go ahead and do that. And that will be it for today, kiddos. So that's coordinate planes. Thank you so much for coming. I'm going to stop recording.